Okay, so I was asked by Arnav to make a few videos on some of these golden problems or important problems that have usually multi-steps and start reviewing those for your exam. So I'll try to make 2 or 3 of these a day to help you guys get yourselves organized. All right, so one of the largest concepts or one of the most challenging ones that kids have when we're learning mechanics is how to resolve forces on inclined planes, if you remember. Okay, so here's an inclined plane. Here's the angle of elevation. This would be 30 degrees. I'm using 30 degrees because it makes some of the calculations easier, okay? And here's an object that's gonna be sliding down the ramp, and here are the component forces. If you remember, this is like my free body diagram. So the first step to solving any problem on an inclined plane is drawing this diagram and labeling forces in the free body diagram. So let's start by labeling it, okay? So this force over here in the middle is my force of gravity. That's the weight of the object due to gravity. And that object applying weight here is going to be interacting with the surface of that inclined plane, which is going to create a normal force. Okay, and that normal force and the force of gravity combined is going to result in the inclined plane basically pushing the object or sliding the object down the inclined plane. All right, so this force here is my normal force. This would be my resultant. That's the combination of the normal force and the force of gravity. And this resistant force over here, I would say, is due to the force of friction. Okay, so those are 4 different forces that we had that in class you guys learned how to calculate. Okay, so the force of gravity, I'm just going to write down how to calculate those forces. The force of gravity is always equal to mass times gravity. Okay, so we have that. Fn is usually, it's the resultant, it's the reaction force. Now, normally if that object was on a flat surface, okay, it would equal to the force of gravity if it was going up like that, but this normal force is going at an angle. All right, so we have to try to figure out how to calculate the force, that normal force, and how to calculate the resultant force. And what we have to remember is that we can form a triangle in here, okay, where that is 30 degrees because they're similar triangles. This triangle inside would show me that that force over there is my normal force, and this over here is my resultant force, and that hypotenuse, the hypotenuse line over here is my force of gravity. So if I want to redraw that triangle, I'm going to redraw it right over here. Okay, this is a right-handed triangle. This is my Fn, that's my Fr, and that's my Fg over here. And that angle is 30 degrees. So if I want to solve for my normal force is going to be a component of the force of gravity linked together with that angle. All right, so I'm just going to label this triangle like we would in trigonometry. This is my adjacent side. This is my opposite side, and that's my hypotenuse of the triangle. So if I want to look at, the relationship between Fg and Fn, that's my adjacent, that's my hypotenuse. They're related by cosine theta. Okay, so cosine theta is equal to adjacent over hypotenuse. Cosine of 30 degrees is equal to Fn over Fg. Therefore, Fg cosine 30 degrees is equal to Fn. Okay, and that's what we're going to put over here. Fn is equal to cos theta times mg. All right, and that's an important thing that you'd have to be able to calculate when we're going to be using Fn. The only place we actually use Fn is to calculate the force of friction, so that'll come back a bit later on. Okay, and then if I want to calculate the resultant force, I'll look back at that triangle that we drew. All right, my resultant force is opposite, okay, to that angle. So opposite hypotenuse. All right, so that's sine theta. So sine theta is equal to opposite over hypotenuse. All right, so sine of 30 degrees is equal to Fr over Fg. Therefore, FR is equal to FG sine theta, okay, or sine 30. Okay, so sine theta times mg is equal to my resultant force. Okay, so if I come back over here, these are three really important equations that we have when we're dealing with inclined planes. How to calculate the weight, which is Fg, you can always calculate that. How to calculate your normal force, which is cos theta times mg, and how to calculate your resultant force, this force over here, which is sine theta times mg. Once I have all those together, I'll be able to then calculate other things. How do we calculate the force of friction? Well, that last part, the force of friction, is equal to Fn times mu, okay, or the friction coefficient of that surface if we're talking about dynamic friction or static friction. So the force of friction is equal to cos theta mg times mu. All right, so that I can call that 1, 2, 3, 4. Now we have all the formulas to be able to calculate all the forces around that sliding object on the inclined plane. All right, so next part, after I've created the equations to resolve all the component forces, how would I find the net force? So let's say the object is sliding down, okay? How would I find the net force? Well, the net force is going to be equal to the resultant force minus the force of friction, okay? Because the force of friction is working in the opposite direction of gravity pulling that object down the ramp, okay? So F net is equal to F resultant minus the force of friction. Okay, that would be the equilibrium. If it's not moving, then they'd be in equilibrium, but since I have the object sliding with acceleration, I would say F net is equal to F resultant minus FF. Okay, and I can calculate my net force by mg sine theta minus mg cos theta, which is Fn, times mu. Okay, and that would give me my net force. So then the last part, which is how do I go about calculating the acceleration? Well, you would then take this and say F net is equal to ma. So therefore, ma is equal to mg sine theta minus mg cos theta mu. Oh, that's interesting. I can calculate my acceleration simply by doing this. I can factor out the m's. The mass is going to cancel out. So my acceleration is equal to g sine theta minus g cos theta times mu. All right, and then I would go and plug all my numbers in there to be able to calculate the acceleration of the object sliding down an inclined plane. And that would be the most complicated inclined plane problem you can get, where they ask you to factor in friction. If there was no friction, it becomes a lot simpler.